All right, hello everybody. As I mentioned, I'm going to go through a couple of practice problems dealing with apparent weight. Okay? So, apparent weight is um, when you feel heavier or lighter because you are accelerating. Right. So the common example is an elevator. Right. When an elevator accelerates upward or accelerates downward. Right. When the elevator just starts moving or up or down. Right. You feel either heavier or lighter, and that's your apparent weight. Okay. Another common place to feel this is, say, on a roller coaster. Right. So when you're going up on a roller coaster, when you go down and you're in that bottom loop after the big drop. Okay. You feel very heavy. You feel like you're being pushed into your seat. However, when you go up over a hill, right, you feel very light. Sometimes your butt even comes off the seat. You feel almost weightless. Okay? So your actual weight hasn't changed, okay, but how you feel does in that situation. Okay? So we're going to look at a question dealing with apparent weight. And apparent weight, anytime you see that phrase, okay, what a question is going to be asking you to find is the normal force that you are experiencing. So depending on what normal force you're experiencing, that is your apparent weight, okay? Whether you're going to feel heavy, lighter, or normal in the situation. Okay. So you are standing in an elevator. What is your apparent weight in each situation? Okay. So I'm just going to use a standard mass here of 75 kilograms. If you were doing this yourself, okay, you would use your own mass. If you have a bathroom scale that measures in kilograms, you can use that. Or if you know how much you weigh in pounds, you just take the pounds, divide by 2.2, and that will give you kilograms. Okay. So let's take a look at the first situation. Right, in the first situation, right, the elevator is not moving. So the normal force and the force of gravity are, right, equivalent. Okay. Right, so the net force equals the normal force minus the force of gravity, because I assigned normal force to be positive and gravity to be negative. Okay. And the net force in this case would be 0, right? You're not moving, so no acceleration, so no net force. So Fn minus Fg. So here Fn would equal Fg. Okay, so when we run this through the calculator, right, we get 735 newtons. Okay, so that's what that's how much you feel that you weigh. And this is just the normal mass, right? Nothing has changed here. Nothing is different, right? This is the same as if you were just standing on level ground. Okay? However, when you are in something that is accelerating, either speeding up or speeding down directions, it's going to change how you feel. Okay, this equation is going to get changed. Okay, so let's take a look at a couple of other examples. So the elevator is accelerating downwards at 7 meters per second squared down, right? Okay, so B acceleration 7.0 meters per second squared down. Okay, so this time everything we are accelerating downwards. Okay, so that means I'm going to assign force of gravity to be positive, right? We're moving down. Okay, so the net force is going to be the force of gravity minus the normal force. Net force is m times a. Fg is mg. Okay, so we get 75 times 7 equals 75 times 9.8, the normal force. Okay. So 525 and this is that 735 from before. Okay, so when we move that over, we get negative 210 is the normal force. So the normal force is 210 newtons. So in this situation, when the elevator is accelerating downwards, you're going to feel lighter, okay? Because you are accelerating in the direction that gravity is also pulling you, so you're going to feel less, right? Basically because the object is accelerating close to what gravity is doing, so the normal force doesn't have to push back up as much, right? So in this situation, you would feel as if you were much lighter. Right? So if you are accelerating downwards, you're going to feel lighter. So your apparent weight, or the normal force you're experiencing, is less. In this situation, right where we have the elevator is accelerating upwards, so I'll assign up as positive and down as negative. Okay. So net force is this time normal force minus the force of gravity, right? Because we're accelerating upwards, meaning the normal force is going to be a larger number than the force of gravity. So we get ma equals Fn minus mg. Okay. Okay, and these numbers didn't change. These numbers 100% do change because we have a different value for acceleration this time. Sorry about that. Okay. So our mass is still 75. Acceleration this time is 3.2. Normal force minus 735, right? Because mg hasn't changed. Okay, so this will be 240. So we get 945 newtons. So what that means is when you are in something and it is accelerating upwards, you are going to feel heavier. Okay? The normal force has to put in more work here, right? So the normal force vector is going to be larger. Okay? So you're in an elevator, it's accelerating downwards, you're going to feel lighter. So your apparent weight, or your normal force, is a much lower number. You are accelerating upwards, okay? The normal force is going to be much higher than the force of gravity, and you're going to feel heavier as a result, right? You're going to feel like you're being pushed down, whereas in the other one, you're going to feel a little bit lighter. Okay? So depending on how the object is accelerating, depends what you feel, what you experience. Okay. Part D says the elevator is in free fall, right? So cable snaps, elevator falls. Okay, the elevator is falling at the same rate of gravity. Okay, so in that situation, right, acceleration is 9.8 meters per second squared down. Okay, so we have our elevator, we have our force of gravity, we have our normal force, and right, we are headed down, so I'm going to make down positive. So net force is going to be Fg minus Fn. So mass times acceleration equals mg minus normal force. However, here, the acceleration is the same as gravity. So what that means is the normal force is 0 in this situation. Okay, so when we rearrange it, we get 0. So what that means is when an object is in free fall, it's accelerating at the same rate gravity is. Okay, you don't have a normal force, right? You feel weightless, right? So when that elevator drops, it's accelerating at the same rate gravity is. So the object you're in is falling at the same rate that you are. So you feel like you are weightless. Okay, you don't experience a force pushing up against you because you are in an accelerating frame. In part E, it says what would happen if the object was in orbit. And the truth is, for this one, this is the same as part D. So being in orbit is the same as being in free fall, right? So when you see videos of astronauts in the International Space Station, right, they are not weightless because they experience zero gravity, right? The International Space Station is still close enough to Earth that it experiences about 90% of Earth's gravity, right? The further away you get from Earth, the less gravity you experience, but the International Space Station, you're still experiencing 90% of Earth's gravity. So why does it look like they are completely weightless? It's because they are in orbit. And when you are in orbit, what that means is basically you are falling around the planet. So you are falling around the curvature of the Earth. So you're just basically falling infinitely, right? So they figured out the right speed and the right height so that the circles the planet in such a way that it's basically falling around the curvature of the planet. So while they look like they are weightless, what's really happening is they are in a constant state of free fall. They're just infinitely falling, basically. However, you don't notice that because the object you are in is also falling, right? And you don't have context of the ground coming towards you because they are falling in such a way that they continuously fall forever, right? When you're falling, in real life, if you fall off, fall out of a tree or something, you can see the ground, you can feel the wind rushing towards you. Your body can put that together, right? But you don't experience that in free fall in space because you have no concept that you are falling because the object you are in is falling with you. Okay? So those are the three different examples. So those are a few different examples of how your apparent weight, so how you feel, changes based on the acceleration of an object that you are in. Right. So if there's no acceleration, your apparent weight is just your weight. You feel normal. Okay. If you are accelerating downwards, okay, you're going to feel lighter. If you are accelerating upwards, you are going to feel heavier. If you are accelerating at the speed of gravity, you are in free fall and you are going to feel like you are weightless. And same thing if an object is in orbit. You are experiencing free fall and you are going to feel weightless. Right? So apparent weight is just the normal force that is affecting you, and it's going to change your perception of how heavy you are. Right? Your actual mass never changes, but what you feel is different depending on the acceleration. And so hopefully that clears some things up for you.